So my name is Chris Exley from Keele University, home of great ceramicists like Josiah Wedgwood, etc. That's Staffordshire in Stoke-on-Trent. We're going to throw a little bit of a spanner into the works here because my group, we're together going to make a presentation which will last over the next hour. So I will start with an introduction, and then my group, Dr. Shardlow, followed by Dr. Mould, and then again Dr. Shardlow, will come to the microphone and complete. So we're doing a single presentation over this next hour. The title, Toxicity of Aluminium Adjuvants, and there is a reason, there's a purpose to use the word toxicity there, because I'm pretty confident that most of us are aware not only that there are adverse events associated with vaccination involving aluminium adjuvants, but of course the reason you get a little red mark following a vaccination is because of toxicity at the injection site. This has got nothing to do with the antigen that you are being vaccinated against. So we shouldn't be afraid of the recognition that the way in which adjuvants work is in some way related to toxicity. The question then arises, do we need to be more cautious? Are there other toxic events associated with aluminium adjuvants and vaccination? So, just flip over there. So I want to open with something which I found, I only just learned about this. And I learned about it through conversations with the European Medicines Agency, with the FDA in the US, and indeed with the manufacturers of aluminium adjuvants. There are no clinically approved aluminium adjuvants. So for a long time, I thought there were. I thought there were two, which we'll talk about, will be the subjects of our talk. But actually, adjuvants, and aluminium adjuvants being part of that, they are only approved as part of a vaccination. And this is really important, and it's important because we are still in our vaccine trials using aluminium adjuvants, or indeed sometimes other aluminium adjuvanted vaccines as placebos or controls in clinical trials for vaccines. And clearly that's wrong, because in that way we are not testing the safety of the adjuvant. What this talk is going to be about is all about what happens from the moment you prepare a vaccine with an aluminium adjuvant through to its injection into, for example, the muscle, into the muscle interstitial fluid. What is happening? What are the physical and chemical properties that we need to understand, both to understand how they work, but also to understand whether or not there is any potential or putative toxicity associated with them. The materials that we are going to talk about, the first and perhaps most prominent is known as Al hydrogel. And as you see some of the details about it here in terms of some of its basic physical and chemical properties, it's essentially a poorly crystalline form of aluminium hydroxide. And as it says at the bottom, it's the most frequently used of the aluminium adjuvants. The other, which I previously thought was a clinically approved aluminium adjuvant, and now we find out that that is not the case, but the other aluminium adjuvant which is used in human vaccination is known as Adjuvants, and this is an aluminium hydroxyphosphate. An important distinction between Al hydrogel, the one I just talked about, and this one is Al hydrogel has some crystalline property. Adjuvants is amorphous, so it is not crystalline in nature. And this could, of course, be very important in understanding how these two different adjuvant materials work in vaccination. There is another compound, it's called Imject alum, which has been used liberally by research scientists as a surrogate for aluminium adjuvants in human vaccination, quite wrongly, simply because actually it's very easily available. You can buy it very quickly and easily, and many people have used it over many, many years in trying to work out how do aluminium adjuvants work. They've used something which is not an aluminium adjuvant. Actually, it's more like an antacid. It's very similar to when you take something to control stomach acid, it's very similar in its properties to that. We shall show some data associated with this product. But bear in mind, first of all, you will see that it's distinctly different from the others, but it is quite definitely not an aluminium adjuvant. It's a research adjuvant used for whatever reason, just simply for convenience purposes. And we need to stop using it, actually. It's giving us no value at all. The people who make it will not thank me for that, but it's the truth. So how do aluminium adjuvants work? That was the task that we set ourselves. And in doing so, could we also provide any possible answers as to why some individuals respond so badly to vaccination containing aluminium adjuvants? I started to think about this in some detail about 5 or 6 years ago. I've been working on aluminium for more than 30 years, and really I only came into starting to think about their application as adjuvants, as I said, probably less than 10 years ago. And about 2009, 2010, I was asked by Trends in Immunology to review this area because there was a massive controversy about how do aluminium adjuvants really work. And many in the immunology field were publishing papers in Nature and all sorts of high prestige and esteemed journals telling us how they worked. Most of those papers were using the aforementioned Imject alum, and most of them were being done by people who had no understanding about aluminium at all. As if you could just take this product off the shelf, any aluminium product, and it would be the same regardless. So I reviewed all of this in this publication in Trends in Immunology. And the area that we are going to look at today is the area in panel A. This is what we would say is the critical area of the injection site. So we want to understand what happens to the adjuvant material, both when you prepare it, and it's usually prepared, as Emma will show you in a minute, in 0.9% sodium chloride, and then after you've injected it, what happens to the material at the injection site, and what can we learn from that about what happens next in terms of the way it potentiates the immune response and the way in which it might have some putative toxicity. So that's what the next part of this talk is all about. So I'm going to hand over to Dr. Shardlow, Emma Shardlow, who's going to talk about her research in this area. She will then hand over to Matthew, Dr. Mould, and then back to Emma to summarize.